Welcome students, measuring space, perimeter and area, exercise 6.2 solution. First question, find the area of triangle ADE in the given figure. Here, this blue color ADE, blue color triangle. This is ADE. Now observe the diagram. The triangle is inside the rectangle. Now AB, the vertex is joining the line ABCD is a rectangle. The triangle is inside the rectangle. So now we know that very well. Area of triangle. Area of any triangle, if we know the height, then half into base into height. This is the formula for area of triangle. Now here the triangle is inside the rectangle ABCD. So we know very well BC is parallel to AD. So that AD length also 8 centimeter. We can say this length also here. This is also 8 centimeter AD length. Now we need to find the height. Height is nothing but if we are dropping a perpendicular line from one vertex to opposite side, that is nothing but the height. Now I am going to drop the perpendicular from E. So if I am dropping a perpendicular like this, then this is my height. This is the height of the triangle ADE. So what about the length of this one? So I am giving the letter here F. What is the length of EF? You know very well here EF is parallel to CD. How we got EF means we are constructing that one. How we are constructing EF is perpendicular to AD. Like that we are drawing a line. Now our EF is nothing but height. So EF is perpendicular to AD. At the same time EF is perpendicular to AD. So EF is equal to height of the triangle ADE. Now EF is parallel to CD and AB, and CD length here given 10 centimeter, so that EF also 10 centimeter, because they are in between another two parallels AD and BC. So EF length also 10 centimeter. So our base here is 8 centimeter, our height 10 centimeter, while we are substituting here half into 8 into 10, 4 times. So area of the triangle is nothing but 40 centimeter squared. Next, second question. The parallel side of a trapezium are 40 centimeter and 20 centimeter. You know very well trapezium is nothing but a quadrilateral whose one of the opposite sides are parallel. One pair of the opposite sides are parallel. Then the quadrilateral is called a trapezium. Now consider this quadrilateral ABCD. Here AB, if we are taking AB is parallel to CD. Now here the information given in the question, parallel sides of the trapezium are 40 centimeter and 20 centimeter. So take a longer side 40 centimeter and shorter side as 20 centimeter. Then second sentence, if its non-parallel sides or both are equal. So this is the isosceles trapezium. So these are AD and BC are non-parallel sides. AB and CD are parallel sides. AD and BC are non-parallel sides. Non-parallel sides, length of non-parallel sides given 26 centimeters. So here also 26 centimeter, here also 26 centimeter. Non-parallel side 26 centimeter. Find the area of the trapezium. So area of trapezium formula, area of trapezium is equal to half into height into sum of the parallel sides. Sum of the parallel sides, not non-parallel, sum of the parallel sides. So you know parallel sides length. One parallel side is 20, another is 40, but you don't know what is height, what is h. So drop a perpendicular from any one vertex. So we're going to drop a perpendicular from vertex A. Suppose we are dropping a perpendicular from vertex A. So this is the height of the trapezium. A is perpendicular from A, we are dropping a perpendicular to next side DC. So this is one height, and another vertex also is there. If we are dropping another height, suppose we are dropping another height, so two heights, both are same because they are the distance between the parallel sides, so they are same. Consider this is our height, h. Now we need to find that length. You know that this is right angle triangle. If I am giving a name A, B, C, D, this is E. Now A, D, E is a right angle triangle. What about H and what about this side? Now from E and this vertex is F. Now length of EF is nothing but AB. Length of EF is 20. Length of EF is equal to AB. AB are parallel, then same height we dropped there. So EF is equal to EF. Length of EF is nothing but AB. Both are 20 centimeter. Now DC, this total length is 40 centimeter, means EF is 20, remaining 20 centimeter. So it should be 10 should be this side and 10 should be this side. So DE is equal to FC is equal to 10 centimeters. So that DC will be 40 centimeters. 10 plus 20 plus 20 nothing but 40 centimeter. Now if we want to find h, means you know very well our Pythagoras theorem. Opposite side of right angle triangle, this is right angle triangle, opposite of this is nothing but 26, that is your hypotenuse. So hypotenuse squared minus another side squared is nothing but height. So 26 squared is 676 minus 100 is equal to square root of 576. Square root of 576 is 24. So height is 24 centimeter. Now we got the height, both the side. Here also 24, there also 24, because the two are distance between the parallels. Now we can calculate area of the trapezium. Half into 24 into sum of the two parallel sides. One parallel side is 40, another parallel side is 20. While cancelling this 2, 12 times, 12 into 60, 720 centimeter squared area. So that we are writing that in square centimeter. So the answer is 720 centimeter squared. Another way is there. Without finding the height, we can calculate the side. We can calculate area of the trapezium. So without finding the height, the formula for that is nothing but area of the trapezium is equal to A plus B of square root of c squared minus b squared, b minus a the whole squared, not b squared, b minus a the whole squared. This is another formula. When we are using this formula, we no need to find height, directly we can substitute. But we must know what is our a, b, c. Square root of, 1 minute, a plus b into square root of c squared minus b minus a the whole square. So for this we need to take our trapezium sides. The lengthier, longer side is 2a, shorter side is 2b. Then only this formula only for isosceles trapezium, not for all the trapeziums. This formula only inclusively, this is for isosceles trapezium. Here given the non-parallel sides are equal, non-parallel sides are equal, so that we can use this formula. If it is, if the non-parallel sides are not equal, you cannot use this formula. So consider the longer side 2a and shorter side 2b and non-parallel side c. So what about our a? That is, if longer side 40 and shorter side 20 means, which means 2a is equal to 40 centimeter, our a is 20 centimeter. 2b is equal to 20 centimeter, our b is 10 centimeter. That is equal to 20 plus 10 square root of c, nothing but 26 centimeter, which is given. Non-parallel side 26 centimeter, that is given in the question. So b minus a or a minus b, because of the square we can take both, but that is 20 minus 10 minus 20 also a squared, then 30 a square root of 26 squared 676 minus 10 minus 20 minus 10 the whole square 100. Then 30 into 576, so 30 into 24, 30 into 24, 0, 12, 7, 720 centimeter squared. So both the questions we are having same answer. Only this formula, only a plus b the into square root of c squared minus b minus a the whole square, only for isosceles trapezium, not for all the trapeziums. Find area of the triangle given that its sides are 8 centimeter, 11 centimeter and its perimeter is 42 centimeter. Consider the triangle, this one, the sides are a, b, c. Then if a is given 8 centimeter, b is 11 centimeter, but we don't know what is the length of c. So to find the length of c, another information here given is perimeter of the triangle. 32 centimeter. We know that perimeter of the triangle is nothing but sum of all the three sides. A plus b plus c is equal to 32 centimeter. A plus b, 8 plus 11 plus c is equal to 32 centimeter. 19 plus c is 32 centimeter. So c is equal to 32 minus 19. C is equal to 13 centimeter. Now A, B, C, all the length we know. When all the three sides length given but the height is not given, we need to use Heron's formula to find area of the triangle. Heron's formula is S into S minus A into S minus B into S minus C. S is semi-perimeter. So perimeter is 32 centimeter divided by 2, 16. 16 centimeter is the semi-perimeter length. When we are replacing our units here, area of the triangle is equal to 16. Semi-perimeter is 16. Then 16 minus A, 8, and 16 minus B is 11. Then 16 minus C is 13. So everything under square root of this. Now 16 into 16 minus 8, once again 8. Then 16 minus 11, 5. 16 minus 3, 3. Now we need to find the values, means find all the prime numbers. 16 square nothing but 4 square. We know very well. 4 into 4, 16. Then 8 is 2 into 2 into 2. Then 5 into 3. So which two number we can take out from the square root? For the 2 4s, 1 4 we can take it out, and for the 2 2s, 1 2 we can take it out. Then remaining no pairs, so we cannot take out of the square root. So write as it is. Now outside 4 2s are 8. Then under the square root, 10 into 3, 30. So this is the area of the square triangle. Given triangle, centimeter squared. 8 square root of 30 centimeters squared. Next question. The side of the triangular plot are in the ratio 3:5:7. Its perimeter is 30 meter. Perimeter of the triangle is given here is 30 meter. So the sides are given in ratio. So how to consider that? Means say one side as 3x and another side will be 5x and the third side will be 7x. When the ratio is there, the common factor should be there. That common factor is nothing but x. So three sides are 3x plus 5x plus 7x is equal to 30. After finding x, we can find the sides length. So 15x is equal to 300. So x is equal to 300 by 15 is nothing but 20 meters. So what about our A? A is equal to 3 into 20, 60 meter. B is equal to 5 into 20, 100 meter. C is equal to 7 into 20, 140 meter. When we are adding this, we are getting 300. So these are our three sides. Once again, we need to use Heron's formula for that semi-perimeter. Semi-perimeter is 300 by 2, 150 meter. So area of triangle is equal to 150 semi-perimeter into 150 minus A first side and 150 minus 100 second side, 150 minus 140 under the square root. Everything under the square root. Now 150 into 150 minus 60 is nothing but 90. Then 150 minus 100 is 50. 150 or minus 40, 10, everything under the root. Now we need to find the square numbers. That is 15 can be written as 150, 10 into 5 into 3. 3 5s are 15 into 10. Then 90, 10 into 3 into 3. 3 3s are 9 into 10. Then 50, 10 into 5. Then into 10. Now for these two 10, we can take one 10 outside. Then for these two 10s, we can take another 10 outside. Now for 5 and 5. So which number and all are having pairs, take it out. which not at all having pair, don't take out. For the 3, 2, 3, take 1, 3 out. So rest of the number here is 3. Without the pair, 1, 3 is there. That should be under our root. So the answer 10 into 10 into 5 into 3, nothing but 1500. So 1500 root 3 meters squared is the area of the triangle. Fifth question. One diagonal of a rhombus is twice as long as the another diagonal if the rhombus has an area of 128 centimeters squared. Find the length of the shorter diagonal. Now say the given information is one diagonal of the rhombus is twice as long as another diagonal. So if D1 diagonal 1 is equal to x units centimeter, D2 nothing but 2x centimeter, and another information given here area of the rhombus is equal to 128 centimeter. We know very well area of the rhombus is 1 by 2 diagonal 1 into diagonal 2 square units. So when we are writing this 2, 1 by 2 x into 2x is equal to, because our D1 is x, our D2 is 2x, that is equal to 128. 2 cancel, x squared is equal to 128. X is equal to under the root 128. If we are finding this one, you can go with prime factorization method, or otherwise long division method. 3 digits are there, so separate first digit, your square numbers 1 into 1, 1, then take both the numbers down, then quotient into 2, we will be getting 2, then you need to find a number here. So 21, 2, 1 into 1, remaining 7, then keep a dot, then 2 zeros. After that we need to replace 2 zeros. Now quotient is 11, 11 into 2, 22, 22, and one more number to multiply here is 22, 4 4s are 8 will not come, 3 3s are 3 3s are 9 6 6. So 3 times 6 6 9. So it will goes on. So approximately we can give the answer as 11.3 centimeter squared, or else we can go with prime factors. The same question can be answered like this also. X is equal to square root of 128. Prime factors for 128, 128, 2 times 6, then 6 2s are 4s are, then 2, 32, then 2, 16. So 16 2 is nothing but 4, 2, 8, 2, 4, 2, 2, 1, 2, 3, 4, 5, 6, 7. So it can be written as 2 into 2 into 2 into 2 into 2 into 2 into 2. So for these two, 1 2 outside, for the next 2 another 2 outside, for the next 2 another 2 outside, the last 2 not at all having pair, so 2 2s are 4, 4 2s are 8, 8 root 2 centimeter. So this is also the correct answer. You can give either in decimal or in irrational number. So both are right. Sixth question, ABCD is a parallelogram. PQ are any 2 points on the side AB. Now, if we are considering the sides, this is A, B, C, D. This is the parallelogram. ABCD is a parallelogram. PQ or any 2 point on side of AB. So, any 2 point, we are going to take 2 point P and Q. Say this point, P, Q. These are the 2 points. What can you say about ratio of PCD? Now join PCD. P2C, PCD. We joined PCD. So this is one triangle. This is one required triangle. Another required triangle is QCD. From Q, QCD. From D. So these are the two triangles. After joining, they are asking ratio of this. Now consider these two triangles. Now triangle PCD and triangle QCD, both the triangles, that is PCD and QCD, both the triangles are in same base. Same base, nothing but CD. Same base CD, and they are in between the parallels AB and CD. But AB is parallel to CD. So both the triangles are having same base, and in between the two parallels, we know very well when they are in between the two parallels, their heights are same. So when heights are same, they are on the same base. Their area nothing but area of triangle PCD is to area of triangle QCD is equal to half into PCD base CD, and height H is to half into CD base and height H. When we are cancelling everything, we are getting 1:1. So area of these two triangle ratio of area of these two triangle 1:1. Seventh question, O is any point on the diagonal PR of the parallelogram PQRS. Prove that the area of the triangle PSO and area of triangle PQO are equal. Now let's take a parallelogram. Consider the parallelogram. naming this, we can take P, Q or S. O is any point on PR. So join the diagonal PR. If we are joining the diagonal PR, we will be getting O point. After joining the diagonal PR, O may be any point on PR. So look at our triangles. The required triangles are PSO and POQ. So we need to take a point nearer to P, not nearer to R. So if we are taking a point here, then you can prove easily. Let's consider this point, O point, nearer to P. Not because the triangle PSO and triangle POQ. Let's join this. If we are joining the triangle, this is triangle PSO. Then next triangle PQO, from O to Q. If you join, these are the two triangles. So we need to prove this. So what is given in this question? Given O is any point on the diagonal. So we took our O here. This is our O, don't forget. This is our O. Given O is any point on PR. We took that, and to prove, we need to prove the triangles, that is area of triangle PSO, which is equal to area of triangle PQO. So in the figure we saw the triangles, no, that two triangles are equal, we need to prove. Now let's join the next. For the proof, we can in proof, first what we are going to do, join SQ, that is the second diagonal, join SQ. So when we are joining SQ, we joined SQ now. So what will happen? We will be getting point of intersection of the diagonals. So definitely the point of intersection of the diagonal and point O, both are different points, both are not same points. This is point of intersection of two diagonals, say this is T. So after joining SQ, let T be the point of intersection of the two diagonals, which means T is the midpoint of PR. That implies T is the midpoint of PR and SQ, both the diagonals. T is the midpoint because we know very well parallelogram properties, the parallelograms, diagonal properties, diagonals bisects each other. So T is midpoint of these two triangles. Now we are going to consider the triangle. We are going to take only the triangle. Which triangle? SQP. So we are going to consider the triangle SQP. Say this point is P and this point is S, this point is Q. So here we are having T. So here we are having T, which is the midpoint. When we are joining the point P and T, we will be getting median. From the vertex to the midpoint, when we are drawing a line, that is nothing but median of the triangle. Now after joining this two, we will be having median of triangle SPQ. So in triangle SPQ, PT is the median, which means median divide the triangle into two equal area triangles. That means PSQ divided as area of triangle PST is equal to area of triangle PQT, equal area triangle, if this is 1. Now consider the next triangle with O. With O we can get another triangle. So take another triangle, see. This is our next triangle. So I am going to take that as small triangle. This one is nothing but O. This vertex is O. This is our S. This is our Q. So in that we can see SOQ triangle. There also T is a point, and here also SQT is midpoint for this also. T is the midpoint. So here we are having T. Let's join OT. Again we are getting median. OT is median of triangle. So OT is median of triangle OQS. So now in triangle OSQ, OT is the median. So here also we will be getting two equal area triangles. So area of triangle OST, which is equal to area of triangle OQT. You know very well, because median divides the triangle into two equal area triangles. Now we are going to subtract equation 1 and 2. Now 1 minus 2. When we are subtracting the equation 1 minus 2, what will happen? That is area of triangle PST minus left hand side area of triangle PST minus area of triangle OST, which is equal to right hand side area of triangle PQT minus area of triangle OQT. Look at here, the full triangle. This is the full triangle. Here you can consider the full triangle P. Look at the diagram, first diagram. PST triangle. If you are subtracting OST triangle, the rest of the triangle nothing but PSO. So left side we will have area of triangle PSO, that is equal to area of triangle right hand side, the full triangle PTQ or PQT. In that OQT subtracted means the remaining area of the triangle nothing but PQO. So area of triangle PQO. So hence proved. Hence proved. That's all, very simple. Separate the triangles and with the median you get two equal area triangles, then subtract it, you will be getting the answer. Next question, 8th question. If the if the midpoint of the sides of the foregone, also known as the quadrilateral, but we prefer to call it a foregone, are joined in order, prove that the area of the parallelogram thus formed will be half the area of the given foregone. You may wonder whether the foregone thus formed is always a parallelogram, and if so, why? Now, take a quadrilateral. So here simply four-side figure given. So take a quadrilateral. We are not going to take a parallelogram or rectangle, anything. Just we going to take a quadrilateral. We know very well quadrilateral nothing but four-sided polygon. Polygon is a four-sided closed figure made up of line segments. So we are going to take a quadrilateral. Sides are unequal and angles are unequal in a quadrilateral. Consider this quadrilateral. If we are naming the quadrilateral ABCD, A, B, C, D is a quadrilateral, and the midpoint of the sides of the foregone. So take P is a midpoint of AB and Q is midpoint of BC and R is the midpoint of DC. S is the midpoint of AD. Now join that midpoints. When we are joining the midpoint, this is the third side. Now we joined the midpoint. Now we got another quadrilateral, four-sided closed figure. Now what is the name of the quadrilateral PQR? Here it is given parallelogram. Why it is parallelogram? Which means if we are drawing the diagonal of the quadrilateral ABCD, this is one diagonal AC, this is one diagonal AC and another diagonal BD. These are the two diagonals. The green color lines are the diagonals. The blue is nothing but the midpoint joining quadrilateral, and ABCD is the original quadrilateral, pink color. Now here consider the triangle. Now take for example, I am going to take one triangle which is I took a triangle from the figure. This triangle nothing but say DBC. This is the triangle. In DBC, we are having midpoint joining the lines. Midpoints are there. P, R, Q. Look at here. midpoints. R is a midpoint and Q is a midpoint. So we are having, I took this triangle, only one triangle R Q. You can see here, I took this triangle. Okay, I took this triangle. I considered this, I draw this separately. BD, C is the triangle and RQ midpoint. We know very well in our midpoint theorem, using our midpoint theorem, R and Q are midpoints of the triangle BCD means RQ is parallel to BD. Like that. If you are taking next triangle ADC, SR is a midpoint joining line which is parallel to AC, and you are considering next triangle ADB. SP is the midpoint joining lines which is equal to the third side BD, and if you are considering ABC triangle, PQ is a line joining the midpoints which is parallel to AC. So we can conclude our PQRS is a parallelogram because of opposite sides are parallel and equal. So it is a parallelogram. So that here it is given the midpoint joining quadrilateral is nothing but the parallelogram. Now what is given here? Given ABCD is a quadrilateral. And PQRS is a parallelogram. And what to prove? To prove, here we need to prove something. No, what is given? We got a parallelogram. No, area of parallelogram PQRS is equal to half of area of the quadrilateral ABCD. We need to prove this. Area of parallelogram PQRS is equal to area of quadrilateral, half of area of quadrilateral ABCD. So for the proof, consider the triangle. Look at the triangle BDC. In that triangle, BCD, we know that midpoint, by the midpoint theorem, R and Q are midpoints. That implies RQ is parallel to BD and RQ is equal to half of BD by midpoint theorem. By the midpoint theorem, RQ is parallel to BD and RQ is equal to half of BD. And for the same triangle, we can see a line from C. If we are joining a line, so consider the this point O. Okay, so now what happened? Height of, what about the height here? Height of triangle BDC is equal to height of triangle, small triangle CRQ, not BDC, CRQ. Height of the triangle. Look at the small triangle there. Same perpendicular they will have. So RCQ, height of triangle RCQ is equal to half of height of triangle BCD. So we're going to consider only one triangle, that is BDC. In that RQ side length is nothing but half of BD, and height of RQC triangle is equal to half of height of BCD triangle. Now, next, area of triangle RQC. We are going to find area of triangle RQC, which is, we know that half of base into height. So that is half of base is RQ. RQ is the base, and height, half of height of BCD is given. Let's take the height of BCD is equal to, if we are taking height of BC is equal to H, means this is nothing but H by 2. Now what is our RQ? We got RQ is equal to half of BD. Replace that one. 1 by 2 into 1 by 2 BD into H by 2. So 1 by 2 into 1 by 2 into 1 by 2, we will be having 1 by 8. So what I going to do? I going to multiply this 2 alone. 1 by 4 into 1 by 2 times BD into H. Now this is the area of, what about what is the area of this triangle? Here area of triangle BCD is equal to half of BD into H. This is the area, half of BD into H. So we can replace that here. That is equal to half of 1 by 4 of area of triangle BCD. Area of triangle BCD. So this is area of triangle RQC. Area of triangle RQC is equal to area of triangle BCD. 1 by 4 area of triangle BCD. So consider this one, the same triangle I am going to take, that is this triangle, no, this one here, that one I took here, this triangle. Here, look at the small triangle, look at the small portion. I am going to draw the line, this portion. This triangle's area is nothing but, this triangle's area is nothing but the full triangle's area with BD, the triangle's area. What is the area of the triangle? In that 1/4, nothing but the small area triangle. Like that, you can take remaining triangles also. For example, I going to find this triangle's area. So this area, that is area of triangle BPQ is equal to 1 by 4 area of triangle ABC. With the diagonal you need to consider ABC, this triangle, the full triangle. Consider this, the full triangle. So the small portion, the line joining the small portion, area of PBQ is equal to 1 by 4 times area of ABC. We will write next triangle, area of PBQ. Similarly, we can write similarly area of triangle BP, see the diagram, BPQ is equal to 1/4 of area of triangle ABC. 1/4 of area of triangle ABC. This is our first equation. This is our second equation. Like that, 4 triangle we can consider. Look at next small, this triangle. Look at this triangle. If we are taking the triangle SRD, area of triangle SRD is equal to 1/4 of area of triangle with the diagonal AC with the diagonal AC, ACD, 1/4 of triangle ACD. This is our third. Next, area of triangle, next small triangle. This one, APS, area of triangle APS is equal to 1/4 of area of triangle ABD, 1/4 of area of triangle ABD. This is our fourth. Now add one first equation plus second equation plus third equation plus fourth equation. We will be getting left side area of triangle RQC plus area of triangle SRD plus area of triangle BPQ plus area of triangle APS, which is equal to 1/4 of area of triangle ABC plus 1/4 of area of triangle ACD plus 1/4 of area of triangle ABD plus 1/4 of area of triangle BCD. Now ABC, triangle ABC, look at the diagram. Triangle ABC plus ADC, you will be getting a quadrilateral. Triangle of ABC, when you are adjoining two triangle ABC and ADC, when we are joining with the diagonal, this is ABC, this triangle, then this triangle ACD, when you are joining this two, ABC plus ADC, that is ABC and ADC, these two triangles, you will be getting quadrilateral. Same way, BD is next diagonal, BD is next diagonal, BD is the diagonal. So ABD triangle, then with that ABD, then CBD, when you are joining this ABD and CBD, again we are getting quadrilateral. So this is nothing but 1/4 of the 1/4 is common, so take it outside. ABC plus this, we will be getting area of quadrilateral ABCD plus, once again we are getting area of quadrilateral ABCD. 2 times we are getting area of quadrilateral, that is equal to 2/4 times area of quadrilateral ABCD. When you are cancelling that, area of triangle RQC, area of triangle RQC plus area of triangle SRD plus area of triangle BPQ plus area of triangle APS is equal to 1/4 of area of the quadrilateral ABCD. So now we need to get which means all the small triangles, sum of all the small triangles area. Look at here, sum of all small triangles area, nothing but 1/2 area of the quadrilateral, but we need area of triangle PQRS. So how to write that? We need to find area of PQRS is equal to area of full quadrilateral ABCD minus area of all the small triangles, area of triangle RQC plus area of triangle SRD plus area of triangle BPQ plus area of triangle APS. If you are adding all the small triangle and subtracting from the whole quadrilateral, we will be getting area of parallelogram PQRS. A, B, C, D. Already we got, this is 1 by 2 times. Okay, 1 by 2 times, I wrote wrongly. Now, so minus, look at this one, all the small triangles area sum is equal to half of area of the quadrilateral ABCD. This is the sum of all the small triangles area. Now the total area minus, for this we can replace that 1 by 2 area of triangle ABCD. So the full area of triangle ABCD minus half of area of triangle, area of quadrilateral ABCD is nothing but half of area of quadrilateral ABCD. That's all. Hence proved. So area of formed parallelogram PQRS is equal to half of area of the quadrilateral ABCD. Hence proved. That is, we are finding the small area, 4 small area triangles are here. We are removing that 4 triangles, that is in a quadrilateral. So consider this is the quadrilateral A, B, C, D and midpoint joining these. When we are joining midpoint P, Q, R, S, we are having the small triangles. So we are finding like this only, summing up all these small triangles, subtracting that from the whole triangle, whole quadrilateral, we will be getting remaining area. The full quadrilateral minus this small, all the 4 small triangles area, we will be getting parallelograms area, required parallelograms area. This is the concept of this sum. So for finding the small triangles area, we are joining the diagonals of the quadrilateral ABCD. AC is one diagonal and BD is another diagonal. When we are joining the diagonal, we will be having parallel lines and base length. Using that, we are finding. Ninth question. In a triangle ABC, the midpoint of BC is D. So you can see in the diagram, the midpoint D is the midpoint of BC, median AD is drawn, P is any point on AD, so that area of APB is in green color, that is equal to area of ACB, that is in pink color. Already we proved this. So same way, we need to find full triangle, that is ABD triangle, because AD is the median given AD is the median of triangle ABC. To prove, very easiest one, area of triangle ABP is equal to area of triangle ACP. So for the proof, we know median divide a triangle into two equal area triangles. So since AD is the median, area of triangle ABD is equal to area of triangle ACD, and this is in triangle ABC. Now in triangle BCP also, PD is the median. PD is the median. So we will be having two equal area triangles. So therefore, area of triangle BDP is equal to area of triangle CDP. Now consider this is first equation, this is second equation. While subtracting 1 minus 2, we will be having area of triangle ABD minus area of triangle BPD is equal to area of triangle ACD minus area of triangle CDP. So that implies area of triangle, the remaining area nothing but triangle BABP, that is equal to triangle ACP. This is our required area. Hence proved. Tenth question, given a square ABCD, let P be a point within it, join PB, PA, PC, PD. What is the ratio of the area of the red region and the green region? In red region, we are having two triangles which are ABP and CDP. These are the two triangles in red region, and green region we are having two triangles PDA and PBC. These are the two triangles you can see clearly in the figure. Now to proving this, we will draw a line through P. So we are going to take a line through P which is parallel to BC. So through P, draw a line through P parallel to BC. So when we are taking a line which is parallel to BC, ABCD is a square. So definitely the line is parallel to AD also. If you are taking one line which is parallel to BC, that line obviously parallel to AB also, since the quadrilateral is a square, opposite sides are parallel. AB is parallel to BC, so that we are taking the line that is also parallel to both the. So I am going to take these two lines. This is nothing but F. So given here A, B, C, D is a square. We need to find ratio of the green region and the red region. For the proof, draw a parallel line through P for line for side BC. That is, EF is parallel to BC, then BC is parallel to AD, EF is parallel to AD also, because ABCD is a square. Now consider the parallelogram. EF is parallel to BC means EFCB is a parallelogram. In parallelogram BCFE and triangle BCP, when we are comparing these two, the parallelogram BC, consider these two, the parallelogram that is parallelogram or rectangle. We can take this as a rectangle. In a square, if we are dividing with the line, it is a rectangle. That parallelogram, particularly the rectangle BCFE. In this rectangle, P is a point. Then adjoining this two, we are getting a triangle. Now compare these two. The rectangle BCEF and the triangle BCF are in same parallels. They are between same parallels, so that tenth question, given a square ABCD. So here given ABCD is a square. So ABCD is a square. Let P be any point within it. Then joining PA, PB, PC, PD, we are getting 4 triangles. So we need to prove the ratio of the area of the red region. That is triangle. In red region, triangle PAB plus area of triangle PAB, plus area of triangle, another red region triangle is nothing but PCD. PCD is equal to ratio. We are going to find the ratio is to area of triangle TBC, green region triangle, plus area of triangle PDA. We are going to find ratio of these two. We are not proving, we are going to find the ratio. Find area of green region ratio is to area of red region ratio. For the proof, for proving this, draw a line through a point P which is parallel to BC. Now we are going to draw a line through a point P. Consider this is the line through point P and this is parallel to the side BC. Many parallel lines we can draw. Now we are going to draw a parallel line through the point P. So draw a line parallel to BC and through the point P. Through the point P, we are drawing a line. Let EF be the line. So, name the line as EF. So, this is EF. Now EF is parallel to BC and EF is parallel to AD also, because ABCD is a square. So now we are going to take a particular rectangle. When we are dividing a square, we will be getting a rectangle. So consider this rectangle. So what is the rectangle? I am going to take a part there. This is, say, this is B, C, F, E. Now BCFE is a rectangle. Opposite sides are parallel. When we are dividing a square, we will be getting a rectangle. Now a point P is there. When we are joining the point P, we are getting a triangle. So here, consider this portion alone. This is one green region. Two green regions are there. This is one green region. Wait a minute. We'll complete the triangle and continue. Join this. So we are having a triangle PBC. Now comparing these two triangles, that is, rectangle is a parallelogram. So parallelogram BCFE BCFE and parallelogram BCFE and triangle BCP are in same base. Same base BC and between same parallels. They are nothing but BC parallel to EF. So one parallelogram and triangle are having same base, and between the parallels their areas are area of triangle BCP is equal to half of area of parallelogram BCFE. Same way, if we are considering next triangle, next rectangle, if we are taking next rectangle ABFE So this is A, B, F, E. Then here we are having a triangle. This is the point P. When we are joining this, we are getting a triangle. So both are green region. So compare this to. Now parallelogram A, B, E, F and triangle A, B, P are in same base and parallels. Parallels are AB parallel to EF, which means area of the triangle ABP is equal to half of area of the parallelogram ABFE. So this is first equation, this is second equation. Now draw another parallel line through green region. See, through P, we are going to draw another parallel line through P. Now this is parallel to AB and CD. This line is parallel to AB and CD. This is GH. Now what we did? Next, draw a parallel line GH to AB through P, which means AB parallel to GH parallel to CD. So we will be having two rectangles. Now we are having two rectangles. This is one rectangle. If suppose this is another rectangle. Now here we are having one rectangle is AB GH. A B H G. Another rectangle GHCD. These are the two rectangles. Here P is a point. When you are joining, you will be getting a triangle. Here P is a point. If you are joining this, one triangle. This is one red region, again joining the point. This is point P, here point P. So these are the two rectangles, and with two rectangles with we are having a triangle. So same concept, triangles and the rectangle, when we are comparing that, parallelogram ABHG and triangle ABP are in same base and same parallels. That implies area of triangle ABP is equal to half of area of the parallelogram ABGH, and parallelogram CDGH and triangle CDP are in same base and between the same parallels. So area of triangle CDP is equal to half of area of parallelogram CDGH. So this is third equation, this is fourth equation. When you are adding 3 and 4, 1 and 2, we will be getting red. 1 and 2, we will be getting green region ratio. So 1 plus 2. Equation 1 plus 2 is equal to left side, first equation, area of BCP, area of triangle BCP or PCB plus area of triangle ABP is equal to half of area of parallelogram BC, area of BCFE plus half of area of second equation ABEF. So when you are joining this two, half is common, we will be getting square ABCD. So this is our area of green region, that is given in the question, area of green region PAB plus PCD. So we got PAB. So here PAB, area of PAB plus area of PCB, triangle PCB is equal to half of area of the square ABCD. Next, this is area of green region. Next, adding 3 plus 4, we will be getting area of third equation, triangle PAB plus area of triangle PCD is equal to half common area of ABGH plus area of CDGH. When we are adding this, we will be getting half of area of ABCD. So if we are finding the ratio, that is area of PAB plus area of triangle PCB is to area of triangle PAB plus area of triangle PCD is equal to, both are same, half of area of square ABCD is to half of area of square ABCD. So that is nothing but 1:1. So the areas ratio of the area of the green region and red region is 1:1. 11th question. In triangle ABCD, D is the midpoint of AB. P is any point on BC and Q is a point on AB such that CQ parallel to D. PQ is joined. Prove that area of PBQ and is equal to half of area of ABC. So look at the diagram clearly. So this is our diagram. So observe the diagram. What is given? Eleventh sum. In triangle ABC, D is the midpoint of AB. P is any point on BC and Q is a point on AB such that CQ is parallel to PD. PQ is joined. Prove that area of triangle PBQ, that is this triangle BPQ, this triangle BBQ, area of this triangle is equal to half of area of the full triangle. For that given, D is the midpoint of AB and another one given is CQ is parallel to PD. These are the two given informations to prove area of triangle BPQ is equal to half of area of triangle ABC. We need to prove that. For the proof, first we are going to join D and C. So here we are going to join D and C. From D to C, if I am drawing a line, this is the median of the triangle ABCD because D is the midpoint. So from the midpoint to the opposite vertex, if we are joining a line, that is nothing but the median of the triangle. So consider the triangle. That is, we are going to consider the triangle ABC. CAB. Here D is a point. When we are joining that, we are getting median. If we are drawing a line, CD is a median, which means ABC divided into two equal triangles. CD is the median of triangle ABC. Therefore, area of triangle ACD is equal to area of triangle BCD is equal to half of area of triangle ABC. Two equal area triangles, that two are equal to half of the full triangle. Next information given here is CD is parallel to PD. So consider the part, that part CD parallel to now we are going to consider this PD and CQ. These are the two parallel lines. When we are having the lines joining this two and this two. Consider this portion alone and join here. So what are the vertices here? Q, C, P, D. Next, our given information is CQ parallel to PD. So these are the two lines, which implies we can see two triangles, that is area of triangle PDQ and area of triangle PDC are in same base PD and same parallels. The parallels are CQ parallel to PD. So these two triangles are in between, same parallels and having same base. So area of these two triangles are same. Therefore, area of triangle PDQ is equal to area of triangle PDC. So now we are having two information. One is our BPD triangle. This one is first one, this one is second one. That is BCD. BCD triangle is equal to half of ABC, and this is next one. Now we can take the required triangle, our required to prove area of PBQ. So take that area of triangle BPQ. Now look at the diagram. Area of triangle BPQ, which is this one. This dotted line. This triangle. This is nothing but area of triangle PBD plus area of triangle DPQ. So we can write this area of triangle PBD plus area of triangle PDQ. Now using our second condition, second equation, we can replace our PDQ as PDC. We got this by second equation. Now joining this PDP and PDC. Look at the diagram, observe clearly. PD, PDP and plus PCD. When we are joining this, we are getting a triangle BCD. Observe correctly. we are getting a triangle BCD. Joining these two, we are getting a triangle, area of triangle BCD. So look at our first equation. Area of triangle BCD is equal to half of area of full triangle. So that is equal to area of triangle ABC. We got this by first equation. Hence proved. Thank you.